All right, we have been talking about some inverse trigonometry. So in each of these things, the x is the angle measurement. Angle measurement, this is the ratio over here. So to work backwards, the angle measurement is equal to the inverse sine of the ratio. So remember, on the sine, that angle measurement that the inverse sine is going to give us has to be between negative 90 and 90. For cosine, it's between 0 and 180. And for a tangent is the same as the sine, between negative 9 and 90. This is supposed to be all real numbers. Okay, the other thing about this is that the ratio, a over b, so for sine that's opposite over hypotenuse, it can only be between negative 1 and 1. Same thing with the cosine. So let me explain that. If I have a right triangle, here's my angle, call it x, opposite side over hypotenuse. Hypotenuse is always the biggest side. So if I take some number and divide it by the hypotenuse, which is always bigger, obviously this number can only ever be in between negative 1 and positive 1. So the same thing is true about cosine. But for the tangent, it's opposite over adjacent. This could be a small number divided by a big number, or a big number divided by a small number. It's not going to make any difference. You can have all real numbers there. So let's try this. I want angle A. Remember, this is the angle. This is angle, and this is the side ratios. I have the sine of angle A equals 0.87. The way that I solve for A, though, is I go A, the angle, is equal to the inverse sine of the ratio, and the ratio is 0.87. So for this, it's like someone had divided the opposite side over the opposite side over the hypotenuse and got 0.87. The way you put that into the calculator is just inverse sine of 0.87, which is second sine 0.87, and we get approximately 60.5 degrees, just rounded to the nearest tenth. For the second one down here, angle B should be equal to the inverse cosine of 0.15. That's the side ratios. So if I put in second cosine for the inverse 0.15, I get about 81.4 degrees, rounded to the nearest tenth. There's an arrow. Okay. On example 6, now here's how we actually use this in trigonometry. I'm looking for this angle theta. I know that the opposite side is 3, the adjacent side is 4. I'm looking for this angle theta. Opposite over adjacent, that's the tangent ratio. So tangent of my angle, which is theta, equals the opposite side, 3, over 4, the adjacent side. To solve this for the angle theta, it's equal to the inverse tangent of 3 over 4. Putting that into the calculator, inverse tangent of 3 over 4, we get about 36.9 degrees. Let's say I wanted this angle up here. I'll call this angle A. I don't have to use trig in order to find that angle, since I already have what theta is. These two angles have to add up to 90 degrees, since this one's already 90 degrees. So on my calculator, all I have to do is take 90 minus the answer that I already have in the calculator, and I get about 53.1 degrees for the other angle.